Ready? Shh, 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 shh. Okay, guys in the back. So here's what. The problem today is this, is that if you were desperate and you were stumped, you're going to have a really hard time plugging and cranking this in. There are really only three ways to graph these, and two of them are problematic. And here's what we're going to do. We're going to have a problem. Why is it doing that? We're going to have a problem that looks like this today. And you don't have to write this down quite yet. Log nev x plus 4 minus 5. You have no idea what that looks like. And here's the problem. If I said, well, just make a chart, you'd be like, how the hell do I even make a chart to do that? Like, how do I plug in numbers to find out the log of 2 to the what will equal what? Like, it's really, really hard. So there are three ways we have to graph it. One way is to use technology. And when you get to calculus, most of the time, that's what your teacher is going to have you do. Is they're going to be like, hey, let's graph this using technology. The second way is a real pain in the butt. And what it says is, hey, we can't do this going forward. Can we try going backwards? We're going to do that for a hot minute, but you're going to see that's a nightmare. And the third way is to use what I've been telling you all year. If you know the shape and you know what these numbers do to it, you can get a damn good close approximation. And that's what we're going to do today. But we're going to start off with a certain thing that we're going to start with. So I need you to watch this. You're going to put pencils down because I do need you to actually watch. Way back in the very beginning of the year, we graphed that guy. And we said that that guy was y equals x squared. Yay. And then we said, let's graph this guy, this little shooting star guy. And I said, you know, these guys are related. They are inverses. They undo each other. And here's what they do. This guy, his little arms are grabbing the Y line. And it turns out this guy is just this guy flipped over and dropped down. They're actually related to each other. One grabs the Y. His inverse grabs the X. And they were inverses. That's how we could do them. And one way to do these graphs would be like graph this guy. And remember when we did the inverse, I said just pick the points and flip them. If you had 0, 1, you graphed 1, 0. If you had 2, 5, you graphed 5, 2. That's how you flipped it over. So the true way that mathematicians have learned to graph logs, because they're weird, is to know this. This guy, ooh, I'm going to move you over, dude. This guy, y equals 2 to the x, we know how to do, and we're going to do it in just a second. And if we flip him, we can do this guy, because these guys, remember, logs and exponents undo each other. They are inverses. So some teachers teach all log graphing as rewriting. It's a pain in the butt. So I think transforming is the smarter way. But we're going to see how to do this. So everyone get their, if you've got, did I give you all the homework, the note sheets? Yeah, did you guys not get these? Why? Okay, so here we go. I would like everyone, we're going to start with this guy. Let's graph this guy. Are you ready? That is the basic problem from 2 nights ago. Let's talk about him. He's nice and easy. He's not scary. Here's what I want you to graph. Let's rewrite him as y equals 1 times 2 to the x plus 0. Right now on your paper, graph this guy. He's not shifted. He's the basic easy graph. He's super, super easy. Do me a favor, get a helping point. It's really easy. And then when you're done, look at your neighbors to make sure it looks right. And then I'm going to put one up. Yeah. It's not different. What do you, I'm sorry. Because to get the actual log graph, the inverse flips over. So here's what I'm going to tell you, and we're going to get there. This graph is going to look like this, right? The log graph flips over. Does that make sense? So that's where we're heading. We're going to take I call it the lazy J and turn it into the lazy R. Does that make sense? Because he flips over. Good question. Okay, so let's take a look at our lazy J. Here's what we know. That's our starting point, right? Because that's the one. Does it move over? No. Does it move up and down? No. Do I have a lava line? I do, right here. And do I have a helping point? Yes. I'm going to plug in 1. I get 1 comma 2. There we go. Is everybody okay with that dude? Everybody's good. Yeah? So here we do. Let me get in a nice flat like point right there. Okay. Here's what we do to do his inverse. We're going to flip him over. He's now going to do all the stuff that he's doing here flipped over, like not even 100% flip, like a 45 degree, like a 90% flip. Like it's like I'm taking this. Actually, God, wouldn't it be nice if I could do this? Let me see if I can actually do this. Let's see if, oh, that's not what I wanted to do. If I can make this work, I'm amazing. Nope, can't do it. Sorry, I'm not that good. Okay, so here's what we're gonna do. We're gonna flip everything over. So what I mean by that, I'm gonna do it in blue. If this is 0, 1, then my new point is 1, 0. Does that make sense? And if my point here was 1, comma 2, my new point is 2, comma 1. Does that make sense? And watch this part. I love this part. If the lava was on the ground, where is the lava now? On the wall, that like on fire. Does that make sense? So now he goes like that. Does that make sense? Yeah. So here's what we're going to do. We're going to mess with that point and move him around just like we moved this guy around. Now that we know it's a lazy R. Does that make sense? Shut up, which is why I realized it, or that's why Isabella realized it halfway through the problem. Thank you for that. Okay, are we ready to try one? So Jackson, as long as you totally understand this stuff, you could probably be playing on your phone, but otherwise, put your phone away. Put your phone away. Oh, I love that you think that away means in your lap. Okay. So here we go. Let's try one. Now, I have a really exciting thing for you to notice. Do you notice that there is a word missing from here? Yeah, there's no helping point. Because guess what? Getting a helping point with logs, really hard. So guess what we're going to do? We're not going to do it. We're going to sketch it. We're going to get damn close. Do I need it to be more perfect? No. If I want it more perfect, I go to technology. Yeah. Yes. That's exactly what a lot of teachers teach. Yes. The problem is when the log problem becomes very complex, rewriting it in that other form becomes a kind of a nightmare. But um, that is how the book teaches it, which makes me feel that is probably how Algebra 2 teachers taught it. And many of you are like, I don't even know what we're doing here because they said, now rewrite it. And you're like, what? So transforming it is our best, most efficient option, right? Okay, here we go. We're going to try our first one. You ready? Y equals log, and we're going to start really easy. To the 3 Now, here's what I want to tell you. That 3 and that 2, that base is not super important. Let me show you what it does, and you don't have to write this down. It always goes here, but the bigger that base number is, the more stretchy he is. Does that make sense? And that's fine. If you need to get perfect, you make it more stretchy. But for our point of view, we're cool. So if you're like, why did you use a 3 instead of a 2? I just get bored with using 2s. There are some teachers who use base 10 and they don't use any base at all there. Still has the same shape, so we're okay. So why I'm doing this problem, you're like, Miss T, that's almost the exact same problem. We're going to do it and fill out our stuff. Are you ready? So the first thing that we do, we know our intercept is no longer at 0, 1. It is always starting at 1, 0, right? So that's our first thing. Now the next thing we look at, are we shifting it? Is there anything added on there? No. Is there anything over here? No. So no shifting. It is just going to be at 1, 0. And look, it flip-flopped. Now, here's the next trick. The next trick is this. When we had this problem back here, this guy, the up and down guy, changed our lava line because the lava was the ground, right? It moved it up and down. But now the lava is on the wall. It's moving side to side. So I'm going to show you where it's going to be. The lava now is the stuff inside because that is always our side to side stuff. So side to side is always going to be in the parentheses, and the extra stuff added on is always the vertical. Remember, this is always naughty because it's in timeout, and it is always side to side. And in this case now, it is also our asymptote guy. This guy is our up and down. He is not naughty. He's the good sibling who always does what he's supposed to, because his bad sibling is the one with the DUI. Oh, wait, that's my own family. So, poor Thomas. There you go. So here's where my asymptote is. My asymptote is going to be dripping right down this wall. Oh, look at this, where Mrs. T blew it. This is my heartbreak. It is going to be, yes, x equals, I almost did it again. Did you see me almost do it again? I know, yes. Oh, and here's a really easy, real quick to remember this. X is here, X is here, yeah. And then this guy doesn't have any letters, so he's one, yeah. Where did the 3 go? Oh, I just took it off. Sorry, I just lost it. I just dropped it off by mistake. No, he just makes it more stretchy, and since we're sketching and not doing a helping point, we don't have to worry about it. So if that was like the number 20, it would make it really stretchy. And if it was the number 2, it just makes it lay over. It would make it even less flatter. So 1/2 would look like this. Okay, so let's keep rolling. That's kind of all we need. We don't need a helping point anymore, right? Well, we kind of do, but we're lazy and we don't care about it. So here's what we need to remember. It's a lazy R. So it starts low and it turns right there. That's it. That's it. Look, do you see how it's kind of an R? Do you see what I did there? I mean, a little R. Don't do that. But yeah, it's a little lazy R. It's a little lazy R. Now let's be brave and fill in our domain and range. Little bit of changes here. So Sean, help me with my domain. Domain is side to side. What counts here? Where can I go side to side? Very nice, because I can't go over here, can I? Can I touch 0 actually though? No, because it's lava, right? So 0 to infinity. And look, that's the switch from the other ones, right? Because we switched the x and the y. Guess what range is going to be then? All real numbers. You guys know it. I'm walking. I'm walking. Guess what? It's slow, but it's going toward infinity. And here, I'm walking. I'm sliding down to infinity, negative infinity. That's it. That's it. Honest to God, that's as hard as it gets. All we're going to do is shift it around, and the stupid lava wall is going to follow with you, right? We good? Okay, let's try one. Here we go. A little bit trickier. Boom. Y equals, ooh, let's try this one. And I'm going to just do threes on everything because why not? X minus 2. You could put a plus 0 if you want, but you don't need to. I'm giving you a sec to give it a try, but I can do it with you in a minute. Nice. Very nice knowing that that lava line's at 2. Excellent. I have a quick answer. I'm on the mic, but yes, they can be fractions. Yeah. Yeah. I can't tell you if it's right or not. I don't remember. Yeah, I'm not being mean. But that is possible. I have a choice on those to either make the decimals in the problem or fractions and decimals out the problem. So I chose to write whole numbers in the problems. So a lot of those might be decimals. Okay, you guys ready to do this together? It's not stupid. We got this. So got to start same place as I always do. 0, 1 or 1, 0. Now I shift it. He's going to go 2 toward Jace, right? But none up and down. None up and down. So 2 toward Jace. I'm going to grab my little pen, move it 2 toward Jace. 1, 2. And so here's where I'm at. I'm at 3, 0, right? 3, 0. And just like Caesar asked me earlier today, he said, why? That's not the intercept anymore. And it's like, yeah, because the whole point of it is to shift it. It's to shift it. So you got that. Now, my asymptote comes along with me. I am running away from the wall of lava, and the wall of lava is following me. So it is going to be, and here's why I didn't remember this from 2 years ago. It's got the x here. Look, it's x equals 2. God, I can't believe I blew that the whole time. And I really want to blame you people for not telling me. I know. I feel like they're, it seemed right up Owen's. I don't know why you're here then. That was the whole point. All year I've been waiting for that. Thank you for nothing. Okay, we're actually almost done. Is that crazy? Because here's what we know. We know the shape and we know where it turns, right? That's all we really need to know. You're doing a multiple choice test. My God, you've got all of what you need. It starts low. It turns right there. It flattens out because it's a lazy R. Swear to God, that gives you so much. There are some of you who can take an SAT or whatever in the future and feel like you're going to be able to eyeball this really and not do a whole lot more work. So here's what I know. My domain on this one is going to be 2 to infinity, but I touched neither. My range is all real numbers. My guy is walking and he's going to infinity, and he's walking down. He's going to negative infinity. There you go. Yeah? Okay, we got 2 more. How about this? What if we do it all together? So this is, if you're walking, you are slowly heading to infinity if you're going this way. And if you're walking this way, you're slowly heading to infinity down. Yeah. Okay. Log base 3, here it comes. Here it comes. Yeah. Yeah, because of the lava line stopped you from going down, right? So on this one, it doesn't, the end behavior of the y just keeps on going. X my plus 2 plus 3. There you go. We're doing it all. We're shifting and shifting and shifting. This is as bad as it gets, and you're going to be like, really, this is not bad. But when you walked in today, if I'd shown you this, you would have been like, nope, nope. And you actually, most of you, not the Algebra 2 kids, but the Algebra 2 tree kids saw this last year. And you're like, no, we didn't. Did you? Huh? Yeah, see? Genius. That's right. That's what it is. I don't think they taught it transformationally, though. They taught it by switching it into exponential form. Huh? You're making that up. You are just so lying to me right there. Yeah. They totally did that. And then they gave you a $100 bill each. Remember that? Yeah, remember that happened? Start right here. Over 2 in the negative direction. Up 3, 1, 2, 3. Blue lava on this one. -1, 3. Yeah? Because it's naughty in those parentheses. Anything in those parentheses is naughty forever and ever and ever. Because remember, that's really our exponent, right? Our asymptote here is x equals 2, -2, because it's naughty. I'm making these all work out. Anyone who's watching the video now is going to get it right. Here's what he's going to look like. He's going to start low. He's going to make a turn there. And we're going to say our domain is going to go from -2 to infinity. Our range is all real numbers. You're getting bigger and you're getting smaller. Math is hard. Teaching math is hard. Last one, best one. You know what's coming. What's the one thing we haven't done yet? We got it. Oh, Hannah, that was the best response. We're going to flip this bad boy upside down, right? So instead of being a lazy R like this, he's going to be a lazy R like this. We're going to flip him. We're going to flip him. But I said, you know what's coming next, and then Hannah knew, and she made that face. That was so good. Y equals, I want this one, you two on the desk. Just do this. This is the only one I'm going to make you do on your desk. But shut up. You haven't even read it yet. There you go. There you go. How do I know it's flipped? There's a negative in the front. If you walk out with nothing else from pre-calculus, you're going to walk out knowing this flips it. This always moves it left and right. And this always moves it up and down on any kind of graph. Exponential, log, square roots, cube roots, everything. You know the shape, you can graph it. Yes. Because I start here at 0, 1, 0, and I'm going to move it 2 to the left. 1, 2, right? And then up there. Hey, if you would do me a favor, if you haven't done it already, real quick, I'm going to stop you real quick. If you're working away, if you don't have your phone, could you grab your phone? Like, look how many over there. That's just sad and wrong. Who is my favorite person? Who's number 7? Who is the awesomest? Oh my God, I love you forever. I'm going to, you know what? Ryan, you're getting candy. I'm giving you candy today because he put his phone up. You're going to take a picture of your homework in a minute because I'm running out of time. Oh my God, I'm so going to give you candy. No, I really want this graph. So it's a regular JR, so it's this way instead. So it's start. So what's going to happen is it's going to, oh God, I got to think about this. Now I'm in my head. Okay, so it goes like this. I got my point. It goes like this. So it's going to go like this. It's going to come down and go like that. Does that make sense? Yeah. For this, so that you flipped it the wrong way. So you're going to have your lava line it's going to come down the lava line and flatten out.
Oh, but don't you?
Huh?
Like,
Yes, we flip it over the y-axis. I mean, over the x-axis. So here's the normal one. The normal one looks like this. So the flipped version looks like that. Let me make sure I got your, what's it called? I'm going to go fast because I'm running out of time. So here I go. I'm going to start right here. I'm going to move it 2 this way. 1, 2, 3 down. 1, 2, 3. Is that correct? Yeah? -3. It's going to be +3, -3. Does that fix you? Yeah? So now my lava line is at +2. That's my drippy stuff dripping down. Now, Henrik and I were talking. The normal one starts low and flattens out. But we are doing the opposite. We are starting high and going the other way. So we go like this. Because we flip it over. So you flip it over, it's over the, yes, it's over the x-axis. Because remember when we graphed U's, we would flip it this way, right? No, it's just, yeah, everyone wants to do that. Okay, so snap a quick pic of this, and I will, that's your homework. I will put up answers. Oh, let me get out of your way. Sorry. You guys did great today.
Oh, so I was looking at that basically because if you have a 3.5 in your head or a certain GPA in all your math classes, 4 years.
See, yeah.
I had a C last year, but I had A's every other year. Will that still even out?
I don't know. I don't know, but that's a good deal. That's a nice deal. Like because they're trying to save kids from having to take those placement tests. What is it? No. Please. Then write it. Lie. You're a lie. That's a liar. You're a liar. It's not your phone. Now you're a thief on top of everything else.